All right, first thing we want to do is derive some of these derivatives. Okay, so let's talk about finding the derivative of tangent first. Okay, right now, the only two derivatives we know are cosine and sine. So what do you think I want to do to tangent to be able to find the derivative of tangent? Tangent in terms of sine and cosine. So let's do that. Okay, so if I change tangent to sine over cosine, then what do I need to do to find the derivative?
You have to do derivative of sine. Oh, no, you have to do quotient rule.
I have to do quotient rule. So the quotient rule says the bottom times the derivative of the top, because the derivative of sine is cosine, minus the top times the derivative of the bottom. What's the derivative of the bottom? Negative sine. Over the bottom squared, which would be cosine squared.
Cosine squared minus sine squared.
The top turns into not cosine squared minus sine squared, but cosine squared plus sine squared, and that should be very familiar to us. Because cosine squared plus sine squared is 1. So I'm dealing with 1 over cosine squared, which is secant. So that is the same thing as secant squared. So that means the derivative of tangent is equal to secant squared. Now we can do that same type of process to find the derivative of secant, to find the derivative of cosecant, and to find the derivative of cotangent. All you got to do is change it in terms of sine and cosine, then use the quotient rule, the product rule. That type of thing will allow you to get the other ones. But we're not going to spend time doing that today. I'm going to go ahead and just give you the other 3 derivatives. So we got the derivative of tangent is secant squared. Next, let's find the derivative of cosecant, and the derivative of cosecant is negative cosecant times cotangent. That's the derivative of cosecant. The derivative of secant is secant times tangent. And that leaves me with the derivative of cotangent. Any guesses on the derivative of cotangent?
Negative.
Cheek dog.
What? What do you mean I'm cheap?
Cheek. How'd you come up with that?
Because it's just like sine and cosine. He's cheated hard for you.
Alright, so those are the other derivatives of the other 4 trig functions. So those will show up in our work that goes along with this. So
there's no pattern.
that is correct. Did everybody hear what Chris just said?
Something smart.
When I take the derivative of something that has co, my derivative needs to be negative. When I take the derivative that has a co in it, the derivative will be negative. The derivative of cosine, negative. Derivative of cosecant, negative. Derivative of cotangent, negative. If it doesn't have a co in it, when I take the derivative, it stays positive. Alright, so let's look at some examples here. We're going to pass over A. We're going to start with B. Very easy, that's why we're passing over. So we're going to start with B. And here's something we need to know. Anytime I'm taking the derivative and a trig function is involved, the inside of the trig function never changes. So anytime I write a trig function down, like on B, what should my trig function always have inside of it? It should always be 2x. So when you're taking the derivative and a trig function is involved, make sure that the inside of any trig function you write down always has the same stuff inside. Because the inside of a trig function will never change when you're finding the derivative. Okay, that is key number 1 on what we're doing today. So make sure it stays the same. Now, what's required on B? What do I have to do? take the derivative, what do I have to do?
Make sure the twist is.
You gotta make sure 2x stays the same, but do you guys see anything else that's going on with that problem?
Y equals.
Alright, so what do you think the derivative should be of this?
Positive.
Should be a positive cosine of 2x? Is that what you're telling me the derivative is?
Probably not. That's
There's
gonna
two cosine to it.
It's gonna be 2 cosine 2x. Why?
I don't know, that was just because you put a space there.
Well, why is there a 2 cosine? Why is it 2 cosine 2x?
Because it can.
Constant coefficient rule?
No?
Okay.
Is it the same rule that applies to sine and cosine?
What was that rule?
Is it because
You
the
have to
inside's
multiply by
2?
something.
It's got something to do with the inside. I've got 2x. I've got 2x that's inside of sine. When I have something inside of something else, what rule do I have to use?
Chain.
The chain rule. So the chain rule tells me I've got to take the derivative of sine. The inside stays the same, but then I have to multiply by the derivative of the inside. So that's where the 2 comes from. Because I've got to multiply by the derivative of 2x, and the derivative of 2x is 2.
So you do chain rule on that?
So I do chain rule on that. Because the 2x, you can think of it as parentheses.
Sine.
So the 2x is inside of sine. Now it's not times. It's not times. The 2x is on the inside. So when you got something inside of something else, that should be telling you chain rule.
Okay.
All right, we're going to skip over C because there's not much difference going on there. But let's go ahead and go to D. I have y equals sine squared x. Now, how else can I think of y equals sine squared x?
Sine x squared.
Sine x. That's the same thing as sine x parentheses squared. So what's required when I take the derivative? I have to take the chain. So I've got 2. Inside stays the same. My new exponent is 1, and then the derivative of sine is cosine. So my derivative there would be 2 sine cosine. Okay, let's talk about E. I have y equals sine squared of 2x. I've got double chain. First thing it's probably best to do on these problems is rewrite it. Because if I rewrite it, that's what I'm looking at. So I've got double chain. Why do I have double chain?
You have something inside of something.
I got sine inside of the power, and then I've got 2x inside of the sine. Now the key is start on the outside and work your way through the inside. So if I start on the outside, my first derivative, the 2 is going to be here. I've got sine of 2x, and my new exponent is 1. Okay, so that took care of the power. So now think of the power being gone. What's the next thing I have to take the derivative of?
Inside.
The inside, so what would that be?
Cosine 2x.
The next thing I have to take the derivative of is sine. So what's the derivative of sine? Cosine. What has to be the inside of cosine? 2x. Why? The inside of a trig function stays the same. So I took the derivative of sine, so now the last thing I need to take the derivative of is 2x, which gives me that. So you start on the outside and take the derivative until you've taken the derivative of everything. So yeah, if I wanted to clean it up, it would be 4 sine of 2x cosine of 2x. There it is. Okay, but the key is start on the outside, work your way in. On the next one, what's my outside function? Sine, so the derivative of sine is cosine. What has to be inside of cosine? Radical x. So I took the derivative of sine. The next thing I have to take the derivative of is radical x. And we all know the derivative of radical x is
1 over 2.
1 over 2 radical x. So there's my derivative. Cosine radical x over 2 radical x is how I could write it, yes. Alright, let's look at 2. I have f of x equals sine of x times cosine of x. do I have to do there? Product rule. So first would be sine times the derivative of the second would be negative sine plus the second times the derivative of the first, which would be cosine. So we're looking at negative sine squared plus cosine squared. Not negative 1. If both signs were negative, it would be negative 1. But since my signs are opposite, I can't do anything.
Unless it's cosine squared minus.
Right, I could, yes, I could do that. What do I have to do to 3?
Product.
I have to do product rule just between the t and the cosine t. Anything special about 4?
No.
No, just take the derivative of each of those individually. Alright, let's look at 5. Now, on 5, where is the square at?
On the outside.
It's on the x. So make sure you know that we're talking about that right there. That's what we're looking at. So that's what I want to take the derivative of. What happens to this 6? It stays there. Derivative of cosine. Sine. What has to be on the inside? Negative sine. What has to be on the inside?
X squared.
X squared. And then the derivative of x squared is 2x. Negative 12x sine of x squared. Okay, where's the square on 6?
Inside. On bottom cosine.
I got that one is cosine. So it's 6 cosine of x squared. So real quickly, that would be 12. Inside stays the same. New exponent is 1, and derivative would be negative sine. 7's a fun one.
Oh, come on. Did you have a square and another square and another?
So let's rewrite it to make sure we know what we're looking at.
Cosine x squared squared.
So that's what we're looking at. If you can handle this one, you should be pretty comfortable with the chain rule. So let's take care of this. So I'll take care of that. That's going to give me 12 cosine of x squared to the first. So after I take care of that power, then I have to take care of the inside, which is, I have to take care of the cosine, which would be negative sine. What has to be inside of that sine? X squared. So I took care of that, and then the next thing I have to take care of is the x squared, which gives me 2x. So if you can follow that, you're in good shape if you can follow that.
If that is, that's fine like that.
Oh, I mean, I'm just, right now, I'm making sure we know how to do the calculus.
Okay.
Okay. Obviously, yes, we'd go ahead and do negative 24x cosine x squared sine x squared. That's what I would like the answer to be.
Okay.
But right now, to save us time, I'm just interested in the calculus.
Okay.
What do I have to do on 8? Quotient rule, nothing fancy there. What about 9? Chain rule,
One chain.
nothing fancy there.
One chain. Anywhere near its top.
Let's do 12. Yeah, 12 looks good.
12 looks fun. 3 chain.
What's my outside function on 12?
Secant cube. Well, no, or secant. Like, chain. The exponent.
The exponent. The cube is my outside function. So that means I need the 3. I need the secant of 2x plus 1. And now my exponent is squared. So that takes care of the cube. After I take care of the cube, what do I have to take care of next? Secant. What's the derivative of secant?
Is it secant tangent.
Secant tangent. What has to be in both of those?
2x plus 1.
2x plus 1. Okay, so I took care of the cube, I took care of the secant, now I need to take care of the 2x plus 1, which would just be
2.
2.
Okay, 6.
So it'd be 6.
Secant 2x plus 1 cubed.
It would be, yep, the secant would be cubed because you got secant squared and you got a secant, so that would be cubed, and then you got the tangent of 2x plus 1.
Ooh.
Alright, let's look at 13.
Yep. Because the derivative of that.
Alright, what happens to 4?
It's remains the same.
It stays. What happens between secant and tangent? Product rule. So I need the first. So that'd be secant 3x. Derivative of tangent is?
Secant, just secant.
No.
Secant squared.
Secant squared. What has to be inside of the secant? 3x. So that would be secant squared. And don't forget the 3.
I remember.
I've got to remember we've got to do the derivative of 3x. So that's first times the derivative of the second. Now I need the second, which is tangent 3x times the derivative of the first. What's the derivative of secant?
Secant plus tangent.
Secant times tangent. So secant 3x, tangent 3x, and don't forget
3.
the 3. So let's clean this up a little bit. I've got the 4. This turns out to be secant cubed, so that's 3 secant cubed of 3x. That turns out to be 3 secant 3x tangent squared 3x.
Even clean, that's not very clean.
There it is.
Anything clean, that's not very clean.
All right, everybody got the general idea of when we're taking derivatives involving trig functions. Okay, all the same rules apply. But the key, the one thing I want you to remember from today is what? The inside of a trig function
Stays the same.
stays the same, never changes. The inside of a trig function never changes. So whatever is inside of the trig function to start the problem, every trig function you write down from there on out should have the same thing on the inside. Okay, do not let that be why you miss it.
And get the derivative of the inside.
And don't forget to take the derivative of the inside. That's correct.
Exactly.